Okay. So sorry about all that. My system just basically crashed, and I couldn't recover it, so I had to reboot. I'm not sure what's going on there, if that was a problem with OBS or what, but yeah. Anyways, looks like we're back up and running. Let me make sure my... Oops. Apologies, that's probably better audio that was on my internal microphone in my computer. Let me test, check. Sorry, I just set up everything really quick after I rebooted, so still just getting everything going correctly. Okay. That's good. That's good. Okay. So, let's see if I can get that link to YouTube here. Okay, so it looks like this is Tovio's video, and I'm just gonna just reference this code here. Let me see, make sure that's not getting cut off. That is getting cut off in OBS. Let's see, just move that. Okay, so this is the code in question, and the question is, I think, has to do with what's being printed off. Okay. So, yeah, that looks good. So let's see what this is. This is an isPrime function, it looks like. Divisor 2, divisor 3. Let's see where this is coming from. Ah, okay, I see. So if we look, let's see if my, oh, again, and it just changes source. Oh my gosh. What a day. What a day for streamings. I have got to figure out something to do about this. Oh my gosh. Okay. So it looks like this line right here is just printing off each value for the divisor. The divisor is not a number. Divisor is kind of an odd term. It's not a number that divides. Sometimes it gets used to mean a number that divides evenly into another number, but it's also used to just mean the lower term of a division problem. So that second meaning is how I would take it in this case. So if I write, and I'll just write this out real quick. Def is prime. We'll take in n. And we'll do the Boolean flag solution. Prime equals true if n equals 1. We'll just do if n, actually just do less than or equal to 1, we'll return false. If n equals 2, and I'm gonna skip that because that logic's actually gonna be handled in our loop. essentially. So we'll say for num in range 2 to int of n over 2 plus 1, print, so this is where it's happening, f 1 2 3 4 divisor num, right? So this is just, the reason it's saying divisor is just because it says it right here. So if we run this code, print is prime of 93, like that, you can see we're going to get all, this is just printing off divisor, and I stopped here just to isolate the process, right? We don't even need to finish the isPrime function, but this will still basically do the same thing. And the reason that this currently prints more is that in Tovio's code, they have if n mod num equals 0. So this tells me if num is a factor of n, if num is or if n is evenly divisible by num. And then if it is, we can say prime equals false, and then break. And that's why Tovio's code only produces 2 lines like that. So this isn't saying that 2 and 3 are divisors of 93. This is just saying it's printing off the numbers that are being checked as divisors. Maybe it'd make more sense if this said like checking, something like that, and then we can return prime like that. Cool, and that says false. And the reason for that is it checks 2, it finds that 2 that n is not evenly divisible by 2, and then it checks 3, and then it finds that n is evenly divisible by 3, and then we return false. So that's what's going on there. Cool. All right, hopefully that helps. Yeah, let me know if you have any follow-up questions with that. But I'm going to assume we're doing good. Okay. Let me just square this up again. Let's see. It's probably good. Okay. Whew. I'm still like frazzled from all the just myriad of technical difficulties from today. Sorry about all that, folks. Cool. Oh. And it's happened again. Oh my gosh. This is Not really acceptable. Dang. Okay, cool. And the issues persist. Hopefully that'll be it. Anyways, alright, let's move on to dictionaries. So last time we left off going through the material, we were talking about dictionaries. So I think I kind of went over some introduction with dictionaries, but yeah. I believe last time I didn't really go in depth. I took a question early on and kind of just jumped into a dictionary problem and kind of playing around with dictionaries. But I wanted to touch on sort of like just a quick sort of descriptive conversation about dictionaries. So dictionaries are a data type that are similar to lists and tuples in that they are a collection of elements. So they bear some similarity to lists and tuples and sets. They are like sets in that they're items. We call an entry in a dictionary, we call it an item. Their items are not ordered. So they don't have an index like a list or a tuple. But with sets don't have an index. They have no mechanism for retrieving a value after you've put it in the set. If you put it in the set, it's not there, so you can get it back out of the set, right? So typically things get stored in other forms, and then with sets at least converted to sets. Once we need set operations, and then we can access those things individually in other forms, or they can live in sets if we don't need to access them individually, which is sometimes the case. With dictionaries do have a mechanism for accessing elements that we put inside of them, but it's not an index, it's a key. And a key is, you can think about it like an index that you have to supply yourself. But rather than being a numbered index, a key can be any immutable type. So it could be a number. Integers and floats are immutable. It could be a tuple, because tuples are immutable. It could be a string, and I would say it's safe to say that usually dictionary keys are strings. But yeah, if you just look at Python's immutable types, a dictionary key can be any of those. So the way we make an entry into a dictionary is we have our key and our value. I'll just do a string. So the value can be any type. It doesn't have to be immutable. So we could have a string, we could have a number, a decimal, we could have a list, we could have another dictionary, etc. Right? So we can put whatever we want in the key. We can put whatever we want as the value for a dictionary. So the value is like the element in a list. The key is like the index in a list. But instead of it automatically being generated, just by the number of elements in the list, it's explicitly given by us. Yeah. So there's an example of a dictionary. And then like a list, if I had a list equal to a list with element, right? This element would be at index 0. I could say print list sub 0. That'll give me element. Likewise, I can do d sub key, and that'll give me value, right? And this key doesn't, of course, doesn't need to be called key. It could be called foo, whatever, and then it'll still give me value. Cool. So I'll say this because I know there's always somebody who asks, well, how do I access the key? You know, like how do I determine what the key is if I know the value? And you can't do that in a dictionary. It's sort of a one-way street. If you know the key, you can access the value located at that key in the dictionary. If you know the value, it doesn't work in the other way, in the other direction. So yeah. Okay, let's see. We also have something called, we can add new elements into a dictionary like this. So lists have, real quick, I'll just do list.append some element, and you know, if I print off the list, obviously it'll have both of those elements in it, element and some element, right? Append is sort of, you know, the canonical way that you add an element into a list. With dictionaries, in my experience, my preference is, and there are a few different ways to add elements into dictionaries, but I find this to be the simplest, and I find it to be like readable and just useful. It's my preference to do it this way. We'll say d sub new key equals new value. Actually, we can have spaces in the string because, let's just do that. And then we'll print off the dictionary. So we have key value and new key and new value as well. So there we go. So this is sort of the analogy of an append. Even though it looks quite different, this is what I do for dictionaries in lieu of an append. And let's just check this out. You can see that this is indeed the same dictionary. They have the same ID for anybody who's curious. All right. Just while we're here, it occurs to me to mention I can't do something like this to create a new key without a value. A key value pair has to go in as a pair. You can't have an orphaned key or an orphaned value. So there's no such thing as just adding just the key without a value. If you wanted to like not commit to a given value, you could just do none or something. So yeah, and then there's not even a way to like assign a value that exists in the dictionary without a key, because what would that even mean? Okay. So we looked at, so this is how to create a new entry. We can reassign an entry, an existing entry. So let's say d sub key. uh, is equal to some other value, right? So now let's try this out. So this up here, key value, and then this right here. Okay. All right, so you can see we've got key and value in the first one, and then key and other value in the second one. All right. So this just, I should leave those in there. Whenever you're learning, I'm trying to go over like some key points. Whenever you're learning a new like collection type, you can think about, there's an acronym CRUD, C-R-U-D, create, read, update, delete, and this is a concept that I lifted from my training as a full stack developer. You'll hear people talk about a CRUD app, create, read, update, and delete, and in the context of it, that idea comes from full stack development in the context of like building an app that basically interacts with stored data in some form. It can be through some web API where you're creating, reading, updating, and deleting entries, or it could be on a database stack of some sort, or a file, or whatever. So it's sort of a CRUD app is just sort of what we think of as like a small but complete kind of application. It's one kind of application. But I found that acronym useful for understanding data structures in general. So anytime you learn a new data structure, like a list or a tuple, or you could even do like a string or a dictionary, to the extent that that type supports those features, which dictionaries do, ask yourself those questions, right? Like, how do I create new elements? How do I create a dictionary to start off with, right? When you use the curly brackets, how do I create new elements? How do I read elements that are in the dictionary? And that's this d sub key syntax, or d sub new key. So if I do d sub key, that's a read. Updating would be this, and then deleting, let's look at deleting really quick. So I could say del, I could delete the whole dictionary, actually. We could do that, and then we get this name error, name D is not defined, right there. Could do that, but del, if you know how to use del, it just does that, to anything. So it's not really unique to dictionaries. But we could use del to delete some specific key from the dictionary. We could say d sub key. We'll just delete it, and then now all of them I'm left with is new key and new value. So that's how we can delete elements. Dictionaries also have a pop method. That will do something similar. Let's call this res equals d dot pop key, and remember the value at key is other value at this point. So if I print off, let's do print res like that. We get other values, so we can capture the value this way and remove the key. And notice my that key was removed. The key called key was removed from the dictionary, and its value was returned by pop. We capture that value. Its name is other value, and or its value is other value, and then we just print that off. cool. So these are some examples of create, read, update, delete. And you can go play around with examples of that. Those terms are a little fuzzy. They're not totally perfectly precise, right? There's multiple things with a dictionary that you could think about as creating, right? Like as kind of alluded to this, like there's creating a new dictionary versus creating a new instance of the dictionary. There's deleting or excuse me, there's creating a new dictionary and there's creating a new element or a new key value pair in a dictionary. And similar with deleting, there's deleting the whole dictionary and there's deleting a certain key value pair from a dictionary. And you can see there's multiple ways of deleting that are unique, right? So del d sub key will just remove it, whereas d.pop key removes it and returns the value. So one is not better than the other. They just 6 of one, half a dozen of the other. You could do basically you could do the job of either one with the other, and it'd be fine. So yeah. Yeah, so those terms are a little fuzzy. You might be able to find multiple kind of interpretations, but it's a good basis. It's a good way to kind of like cover your bases in terms of exploring what you can do with a data type. Okay, let's kind of dig into this stuff now. This is just going over a few kind of different ways of declaring dictionaries and building dictionaries. It's often that you'll see the dictionaries formatted in kind of special ways across multiple lines like this. So that's fine to do. Notice the curly brackets around the dictionary delimit it, so it's fine to spread it across multiple lines. Okay. Cool. I say let's just jump into the challenges. Let's just go for it. Okay, so does this code follow the correct syntax for declaring a dictionary? Now, I'm dyslexic, so I couldn't tell you, honestly. Let's bring this into the environment and take a look at it. Okay, so we have looks like a key and a value, and looks like we're describing a dog. A dog is an animal. Its name is dog, and it's got 4 legs. It makes a bark sound. Its name is Spot. Its age is 15. You know, I'm starting to have an emotional attachment to this dog. Sounds like a good dog. Anyways. So yeah, this looks correct to me. You can see we have this key colon value pattern. And I apologies, I kind of formatted this in the way that I often do. There's a few ways I'll actually format dictionaries. Yeah, so this does look correct to me. So I'm going to say true. It's not. Oh, because we're using this dict keyword here. Yeah, I just automatically changed that. I'm like, oh, I'm writing valid code, and I see this, and I'm just like, oh, I've got to get rid of that. That's funny. I can't help but like I just fixed the error with it without thinking about it. So this is kind of funny. The dict keyword or the dict function will convert something to a dictionary, but it's kind of weird what it will convert. Specifically, this is very specific. Dict will convert a list of 2 wide tuples. So let's look at a list of two wide tuples. I'll just turn this into a list of two wide tuples. So let's call this top list equals a list, and we'll do this. Oops. Oh my gosh. Is that going to screw things up? Nope. Oh my gosh. It worked. Sorry, let's do this. So these will be commas, and then we'll do that's not gonna work. Okay. So this might seem really weird, like why would it convert, I mean, the structure is obviously like dictionary, oh shoot, is obviously dictionary like. I don't think anybody would have a hard time like understanding that this is dictionary like, but how does Python know to convert specifically a list of two element tuples to a dictionary? Well, there's sort of a historical reason for this. A lot of older languages have types that are they either have types similar to lists or similar to tuples. And I'm saying two wide tuple here, but this could be a list of two wide lists, or a tuple of two wide lists, or a tuple of two wide tuples. Any structure, any like matrix where the row dimension, I guess, is two elements. Yeah. So back in the let's say the before times, before we had languages with all the features, you had to make your own data structures out of pretty primitive data structures. So dictionaries as a term and as a data structure predate dictionaries as a like object that's built into your language. So if you're learning Python, Python has all these really well built, nicely developed types that have a lot of features and a lot of safeties built into them, right? Like with a list, you can't, if you have a list of 5 elements, you can't just index to like whatever is in whatever data is in the RAM address at the element beyond where that list ends. There's a bunch of things like that where Python just prevents you from doing insane things, and that's because it's a nice modern language. And one of the nice modern features is that it has dictionaries just built in, ready to go for us. Whereas before, like, you would have to make a dictionary out of something like this, and you'd call it a dictionary or a hash table or a hash map or something. But yeah, so a dictionary is an older data type. It's older than, well, I guess the structure is older than the type. So at any rate, like, programmers have been thinking of this structure as a dictionary long before dictionaries were actually, long before Python, I guess. Let's put it that way. Cool. I'm not seeing any activity in the thread. Just want to give people a reminder. Do feel free to ask questions if you've got any. I know somebody asked a question. Hopefully they were able to get the answer that they wanted. But I'm not entirely sure because of the technical difficulties. So yeah, if you got the answer you wanted, let me know. If not, feel free to put any follow-up questions that you have in there, and I'll take those too. But yeah, if you have a question, feel free to throw it in with a link, and I'll take it as soon as I can. Cool. All right. Declaring dictionary challenge. Write 2 dictionaries. The first should be called empty dictionary and will contain an empty dictionary. Oh, okay. The second dictionary should be called dog and should the first key should be called legs equals legs, and the value should be 4. The second key should be called sound, and the value should be, whoops, there you go. Value should be bark. Meh. Okay, I probably misspelled something. Oh. Did I just put a space in front of bark. I don't know why I did that. Cool. That'll do it. Okay, complete the function called return dict of vowels. It takes 4 tuples as parameters. Each should have a length of 2. I see where this is going. Where the first element will become the key. Okay, cool. So what I'm going to do, actually, this is super cheaty. I'm going to say return dict of a tuple of tuples. And this is that data structure that I was talking about. There we go. That'll do it. Now let's say you didn't know you could do it this way, which is fair. We could also do something like for tup in this. We could do a list of these tuples or a tuple of these tuples. I'll do a tuple of tuples here. You could say D equals empty dictionary, and then just copy in D sub tup sub 0 equals tup sub 1 and return D. We could do that. That's also a working solution. We could also deconstruct this tuple in the for loop, like you would with enumerate or something. We could say K and V, and then we'll do K here and V there. And that'll also do it. Good. All right. Let's see here. Okay, so adding key value pairs. So I kind of covered this. Actually, I did cover this. Yeah, well, I guess there's some more we could cover about, Writing a dictionary accumulator can be a little tricky. Let's see if there's a section on this specifically. That's at the end. Yeah, so this is just going to cover kind of simple adding. Okay, so fill in the empty dictionary below by completing the following steps. Add a key called name, age, and job. Okay, so we'll do person sub name equals Clark. We'll do this. Age, job. Job will be future data scientist. And age we'll say is 978. I know I don't look it. Cool. There we go. Complete the function called add val to dict that takes two arguments. The first should be a dictionary. The second should be a tuple containing a key as the first item and a value as the second item. This function should return a copy of the dictionary with the key value pair added. Okay, cool. So we'll say D1, then we'll say D1 sub tup sub 0 equals tup sub 1. Turn D1. Cool. So they gave us the copy to start us off here, so I don't have to worry about that. And then from here, I just need to make the first element of the tuple the key. So to access the first element of the tuple, that's tup sub 0. To make it the key, I just do D1 sub tup sub 0, since tup sub 0 is the key value that I want. Then we have, I'm just setting that equal to tup sub 1, since that's the value that I wanted to use. Write a function called letterIDX. Okay. I seem to remember this one. Or the name sounds familiar. I actually don't remember it. Okay, so write a function called letterIDX that will track the indices of where the vowels occur in the string. Okay, so I see. So if we look at this, this gives us a dictionary containing the vowels that were found from the string as the keys, and the values are a list of the indices where that vowel was encountered. So something to note, I do remember this now. I've helped several people with this, and with several similar problems where the dictionary that was being returned in some cases contained all possible vowels, and then like empty lists for the ones that weren't encountered. But notice in this expectation, it only has the vowels that are members there. So we'll say def letterIDX. We'll take in a string. I'm going to call it text. And we'll start an empty dictionary and return that dictionary. And I'll say for character in text. Now I want to add in the keys if they're not already there. And then if they are there, I want to append the indices. Since I need the indices here, I'm going to enumerate as well, and I'll take in I, or I'll pull out I and C from the enumerated text. So the first thing is to add it in if it's not in there. So D sub C equals empty list, and we could say that the list contains I in it. So this will kind of work. Obviously, it's only if C is a vowel. So let me do that part first. So if C in A, E, I, O, U, and Y, for this exercise, Y is considered a vowel. Okay. A, E, I, O, U, Y. Oh, let me complete that code. There we go. So this will do it only if it's a vowel. So this does give me only E and O, which is good. But the values are wrong. We have a list of 10 and 4, right? So this adds a new key value pair, but I only want to... The problem is it's also overwriting prior instances, and what I want to be doing is adding to this list every time, right? So what I could do is say if C not in D, if our character is not in the dictionary, then I'll add it in, right? And I'll actually add it in empty. I'll add in an empty list. Then I'll say D sub C, which is a list, which I can prove by just printing off D sub C. D sub C is a list. So D sub C dot append I, like that. So what this does is, and you could do this in like a different order. There's a number of different ways to lay this out. I prefer to check if C is not in the dictionary, and if it's not in, then to add it in with the appropriate type as its value in sort of an empty form. So this is just sort of a check. You can think about this line as a check. Oops. Come on. To see if the dictionary contains C as a key. And we can actually check keys like this. This is the same as just leaving keys off in this case, but usually I'll actually put keys just to make it more explicit. But if you don't put anything in and you do a check for membership of a dictionary, it will check the keys only, not the values. So this is going to tell you if C is a key in the dictionary, not if C is a value in the dictionary, even though I'm not specifying key or value. That's just the assumed behavior. So this line just checks to make sure that I have something to append to, and if I don't, then it's like, oh well, I'll make an entry called D sub C and set it equal to an empty list, and then append to that empty list, or to that list, whatever is in it. Cool. So that's my preferred way of doing it. But yeah, like I said, you could lay this out in a lot of different ways. We could do something with like an if-else. We could start I in there, and we could say else append. That would do the same thing. In this case, I need to put I in there, otherwise I'm going to miss that first occurrence, right? Because I'm not doing the append. So to me, it's just like, just start it empty and then immediately accumulate into it. So that makes more sense. Of course, we could also do something like this. If C in D, then append, else add it in with I, something like that. Yeah. But like I said, I figured the solo if is just nice, and this to me just reads as, hey, make sure it's d sub c exists and contains a list before you append to it. So this justifies the next line, which is to append. Like I said, that's my preference. Cool. Accessing dictionary values. Um, Yeah, so accessing a dictionary value. Well, I'll just use this dictionary here. Just use this output. As an example. Oops. Okay, so we'll say D. If I want to access this value under E, I'll have to say D sub E. And I'll just print that out. There we go. And there gives me that list, 1, 8, 10. Cool. So that's all there is to that, basically. So when working with the dictionary, it's always best to, let's see, check to see if the key is in the dictionary before trying to access it. Let's see, add a new key. If it isn't in the dictionary, always check for a repeated key in the dictionary. So this is this is impossible. You can't have two of the same key in a dictionary. So no, it's not that one. To get an error thrown so that so that way it's known that the key isn't in the dictionary. I'm going to say check to see if the key is in the dictionary. That's my guess. Okay, so in this case, they're checking to see if snake is a key in the dictionary, and then printing off D sub snake if it is. Okay, so it's actually a good point. If I try to ask for a key that's not in the dictionary, so let's say I, this will just give me a key error. It just says key error I. If you get a key error, I mean, obviously, there's nothing else here. It just says key error and then just something. So you're just supposed to know that a key error tells you the key that it couldn't find. It just says, oh, it's implied that it looked for this key, but it couldn't find it. So that's what a key error means. So in order to get around this, you can say if I in D, then we'll print D sub I, or whatever. This could be A. Oops. Right? Or it could be E. There we go. There's a method built in that kind of does this for us. So it's called the .get method. So it's a safe way to access a dictionary element. So we could say print d.get, we'll say I, And then get takes an alternate. I think, yeah, so if you pass it one argument and that key is not a member of the dictionary, it's going to return none. But it actually gives us the opportunity to do something else. So I could say, if it doesn't find this as a key in the dictionary, .get will return whatever I pass as the second argument here, or whatever is returned to that, our second argument. So I could say that key is not in the dictionary. Right? If I do E, then it's going to do that. So in this case, maybe I would just do empty list just to keep the types regular. So if I ask for I, I'll get an empty list instead. So .get can be really useful if you're trying to access, not necessarily like update something, but just access something, right? Then .get can be very useful. Cool. Okay, so write a function named check dict that takes two arguments, a dictionary, first argument, and potential key to that dictionary, second argument. Cool. Oops. So if the key is a member of the dictionary, the function will return its value. If the key is not in the dictionary, the function should return a string that says that key is in the dictionary. So this is basically just what I described with .get. I have a feeling they don't want us to use .get, though. Okay, so I'll say yeah, we'll do that. And then I'll say if k not in D, return that key is not in the dictionary, else return D sub k. And then let's just test this really quick. We'll do a dictionary of hello world, and we'll see if hello, and we'll see world. Okay. All right, so the first one returns us D sub k, right? If the key is in the dictionary, the function will return its value, yes. If the key is not in the dictionary, it will return the string. That key is not in the dictionary. Cool. There you go. So that'll work. But this basically, oops, cancel the tests. Let's see. Yeah, that's actually going to work. Okay, good. This is
this just mimics the .get function that I was just talking about. So we could do like this, d.get, and then get rid of that, and that, and that. And that'll give us the same thing. So .get can be a very useful method to know. Okay. So write a function called observation adder. Let's write some tests. Print observation adder. Def observation adder. Okay. Takes two parameters. First parameter is a dictionary of objects called dict of obs. Oops. This dictionary will have strings as keys. These strings represent the names of things, people, animals, etc. The values, let's do this. The values associated with these keys represent the number of items the key, or the number of, the number of times the key was observed. All right. The second parameter, called seen, is a key that may or may not be in the dictionary. Okay, so dict of obs and k. So this function should see if the key is in the dictionary. If it is, the value associated should be incremented by 1. If it's not, okay. If it's not in the dictionary, it should be added to the key in the dictionary, added as a new key in the dictionary, and its value set to 1. Okay, so let's do this. Let's call obs dict equals, and we'll say bird 4. We've seen 4 birds, and we've seen dog. We've seen 7 dogs, and we've seen cat. We'll say we've seen 2 cats. So, I'll do this. Obs dict. No, I don't need to do that. What am I doing? Obs dict, and we'll say cat. So we see another cat. So we expect this to give me back this dictionary, like this. And then let's do another test. And I'll test it on the same dictionary. So I'm going to write this in a way where it doesn't alter its input, which is the way that you should always write your functions if you have a choice. So let's say we see a frog. So in this case, We want to keep cat at 2, and we'll say frog gets 1. Okay, so that's what I should get for these two tests, and let me just collapse these a little bit. Okay. There we go. Okay, so let's see. So I guess we can just say if k in dictive obs we can return. Yeah, it'll be dictive obs sub k. Else, and we should probably do this. D equals dictive obs dot copy, and I'll just use D from here on out. So else, we'll say D sub k equals 1, and we'll just return D. Okay, so did I get this right? The function is to see if the key is in the dictionary. If it is, the value should be accessed with the key. The value associated with the key should be incremented by 1. Oh my gosh. So we're returning D either way. So I didn't want to do this. I wanted to do D sub k plus equals 1. Okay, there we go. I was like, I don't think I did this right. Okay, that seems better. So this gives us cat with 3, and this gives us cat with 2 and frog with 1. Okay. Trying to think if there's a way to do this. I'm trying to think if there's a way to do this in one line. And I'm thinking we could do, I think we could do return dictive obs dot get k. Okay. And is that going to give me what I want? No, it's not going to give me what I want. I'm pushing a boulder up a hill. This is going to be easier to just do this way. Probably is a way, a slick one-liner way, and it's probably really obvious. If you know it, go ahead. Feel free to put it in Slack, just for fun, but I'm not going to waste any more time on that. All right, cool. So we are at our normal stopping point. I think I'll wrap up here for the day. Yeah, sorry for the technical issues. It's just kind of some crazy stuff. I'm still getting things set up on this new machine in terms of just like playing around with software and just different configurations. And I think I think I'll have to like rethink some of the ways I'm doing this, but lesson learned, and next time will be cleaner. Do let me know if you have any further questions. Feel free to reach out to me. I'll get back to you as soon as possible. But yeah, You all have a great rest of your evening, and I'll see you next study hall at, on Wednesday. Or if you're in premium prep, I'll see you this evening. Cool. Bye bye.